we're going to look at some matrix operations, and we will look at a few different ones. But first, we need some notation. A matrix with m rows and n columns is said to have size m by n. When we list size, we always do rows first and then columns. A matrix with a single column is known as a vector. And we usually use capital letters to denote matrices, and these letters with a little arrow over them to denote vectors. You can also see them as boldface type whenever you are typing them. However, we're not typing here, so we use these arrows to indicate that they are vectors. And finally, a little a sub ij denotes the entry in matrix A that's in row I and column j. Just like with the size, we do the row first and then the column. The first thing we'll talk about is adding matrices. And we add matrices by adding things that are in the same spot. And that's it. We look at entries that are in the same spots and add them up. If the matrices are two different sizes, we cannot add them. So we can only add matrices that are the same size. And here's an example. We have these two matrices, A plus B, and I add them by adding things that are in the same spot. I start with a -4 minus 4 is -8. I then do 5 minus 8 is -3. 2 minus 7 is -5. And then I'm going to move to my second row. 9 plus 2 is 11. 6 plus 2 is 8. And then finally 9 minus 9 is 0. So I have found the sum. And we can subtract matrices as well, the same way we added. This time we'll subtract things that are in the same spot. -4 minus -4 is 0. 5 minus -8 is 13. 2 minus -7 is 9. Second row, 9 minus 2 is 7. 6 minus 2 is 4. And 9 minus -9 is 18. We will define a special matrix for addition, which is called the zero matrix. And this is any matrix that contains all zeros, and we usually denote it by just a 0. The size of a zero matrix can usually be interpreted based on the situation. If I say something like A plus 0, I want to define the zero matrix so that addition is actually defined. And there are a few properties of matrix addition that we'll look at. The first, A plus B is the same thing as B plus A. I can switch up my order of addition. I do still have my commutative laws. I also have that A plus B plus C is the same thing as A plus B plus C. So my associative law still holds. And then finally, A plus the zero matrix is equal to A. Adding 0 will not change anything. The next operation we'll look at here is scalar multiplication. And this is a way to multiply matrices and numbers. A scalar is just another word for number. And when I multiply a number times a matrix, what I'm going to do is multiply all of the entries in that matrix by this number R. For example, we have this matrix A, and if I want to do -2 times A, I would have -2 times 7, which is -14. -2 times 0 is 0. In my second row, -2 times -8 is 16, and -2 times 8 is -16. My last row, -2 times -9 is 18, and negative 2 times 4 is negative 8. Finally, we'll give a few properties of this scalar multiplication. First, if I am multiplying a sum by a scalar, I can distribute that. I can either add the matrices first and then multiply by r, or multiply by r and then add. In addition, if I'm adding scalars and then multiplying, I can also distribute that and multiply my matrix by each scalar and then add. And then finally, if I'm multiplying by more than one scalar, we can do this multiplication in any order.